How to graph y equals the secant of x using the unit circle values with proper vocabulary, part of the Family of Functions series. You will need paper and a straight edge, or you can download this PDF and print it. Press pause as needed any time during this video. Graph y equals the secant of x. Note, we are proceeding with the assumption that students know the unit circle values for the secant function, its domain, range, and where the secant function is undefined. We will plot the secant function from x equals negative pi over 2 to x equals 2 pi. Pause is needed to set up your graph grid. First, we will draw dashed vertical lines where the secant is undefined. Recall that the secant is the reciprocal of the cosine. The secant is undefined when the denominator is 0, that is, when the cosine function is 0. When we draw the graph of cosine, we can see it's 0 here at pi over 2 and at 3 pi over 2. So we're going to put a vertical dashed line at x equals pi over 2, x equals 3 pi over 2. In fact, the secant is undefined at any odd multiple of pi over 2, also including negative pi over 2. So here are our 3 odd multiples of pi over 2 in this particular domain. Next, we'll plot the points from the first quadrant with a table. Pause to complete the table. And here are the values, and we are going to need to get some decimal approximations, so I used both an 84 and an Inspire to approximate those. Pause is needed. Resume when you're ready. So I rounded them to 2 decimal places, and we'll go ahead and plot those points. Starting with 0, 1. Our markings are pi over 12, so I'll go over 2 pi over 12 and up 1.15 for pi over 6. To the right, 3 pi over 12 for pi over 4 and up about 1.4. 4 pi over 12 is pi over 3, up exactly at 2. And of course at pi over 2 it's undefined. Let's look at values of x that are close to x equals pi over 2, but strictly less than pi over 2 when we're talking about right here on the graph. For example, pi over 2 is this number to several decimal places, so a number close to that would be 1.5, but less than it. So I went ahead and took the secant of that and got 14 point something. I then tried 1.57 and found the secant of that, and it, whoa, 1255 point something. 1.5707 and 10,000 something. So from the table below, it's clear that as x gets close to pi over 2, but smaller than pi over 2, the secant is getting larger and larger. So connecting the points, the graph is a nice curve and then takes off, and as closer it gets to pi over 2 from the right, the faster it goes. Let's analyze what is happening to the graph of that as x is close to or approaches pi over 2 in another way, again from the left side. We're going to need some shorthand notation. We're going to use this x arrow pi over 2 and negative sign as the, looks like an exponent there. This means that x is getting very close to pi over 2, but from the left, the negative sign from the left. Or that x is approaching pi over 2, but strictly smaller than pi over 2. Pause is needed. So we're going to analyze the graph of secant as x approaches pi over 2 from the negative side. The secant again is the reciprocal of the cosine, so we'll look at the cosine graph. And x is approaching pi over 2 from the negative side right before here, right before it hits the x-axis. X is getting very close to 0. I'm sorry, the cosine of x is getting very close to 0, but a positive number. So an example might be 1,000th. The secant would be the reciprocal of a thousandth, which would be 1,000. And that would be way up there, way up there. Another example would be the cosine would be 100,000th. And when we take the reciprocal, we get 100,000, which is even way further up. So as x approaches pi over 2 from the negative side, the secant, which is the reciprocal of the cosine, is increasing without bound. That's the phrase we're going to use. It's getting so large, we just larger and larger, increasing without bound. And the line x equals pi over 2 is a vertical asymptote, kind of like a boundary line. Pause is needed. Next, we'll plot points from the second quadrant with the table. Copy and complete the table. These are the values that we got, and then we'll also use decimal approximations. Notice in the second quadrant they're negative. Cosine's negative, secant's negative in the second quadrant. Plotting the points. Pi over 2, it's undefined. 2 pi over 3, which would be 8 pi over 12, down negative 2. 9 pi over 12, down to negative 1.4 approximately. 10 pi over 12, which is 5 pi over 6, about negative 0.15. And at pi, it's exactly negative 1. Let's go ahead and do the third quadrant while we're there. We know the values are going to all be negative there as well. Pause to complete the table. And these are the values we get, again, negative. Plotting the points, pi negative 1 is already there. At 7 pi over 6, 14 pi over 12, negative 1.15. 5 pi over 4, negative about 1.4. 4 pi over 3, exactly negative 2. And at 3 pi over 2, the cosine is 0, so the secant is undefined. So I'd like to look at what's happening here, okay, right around the asymptote, on the other side of the asymptote. So we're going to analyze as x gets close to or approaches pi over 2, but from the right-hand side. We'll use shorthand notation, x, arrow, pi over 2, and then a plus sign for the exponent. And this means that x is getting very close to pi over 2, but from the right-hand side, or that x is approaching pi over 2, but strictly larger than pi over 2. Pause is needed. As x approaches pi over 2 from the positive side, the secant, which is the reciprocal of the cosine, we'll look at the graph. And as x gets close to pi over 2 from the right-hand side, from the positive side, we can see that the cosine gets really close to 0 again, but negative this time. For example, a cosine could be negative 1,000th, and the reciprocal of that would be negative 1,000. Which is way down there. Another example, negative 100,000th. Reciprocal of that would be negative 100,000, which would be even further down as we get closer and closer to pi over 2 from the right-hand side. We say that the secant of x is decreasing without bound when this happens. And the line x equals pi over 2, again, is a boundary line called a vertical asymptote. A similar argument could be made for the line x equals 3 pi over 2 over on this side. Return to the graph and connect the points. So connecting the points here, from pi to the left, it's going to go concave down, and pi to the right, concave down. Infinitely. Complete the table for the fourth quadrant. Pause is needed. In the fourth quadrant, the cosine and the secant are positive numbers. So we'll go ahead and plot the points. At 3 pi over 2 is undefined. At 5 pi over 3, positive 2. 7 pi over 4, about 1.4. 11 pi over 6, about 1.15. And at 2 pi, right where we started, back at 1. Connect the points. And again, we're getting that half of a U-shaped curve like we got here in the first quadrant, just going the other direction. So let's go ahead and complete the graph here. Going from 0 to negative pi over 2. You can see it's going to go back the same way. And we're also going to graph the cosine on the same pair of axes in a different color. Pause is needed to do so. So I plotted the key points, concave down, concave up, half of a concave down. And now pause to reflect about how these two graphs are related. And you can see that when the cosine is 0, the secant is undefined. That's one way. And also, think of this. Here it's concave down, but when we take the reciprocal, it's concave up. Here it's concave up. Take the reciprocal, it's concave down. So there's definitely a relationship between how the curve is shaped with both the reciprocal and the original function. And here's a beautiful looking pairing of those functions. Finally, we'll look at the domain. It looks like the domain will be all real numbers for the secant except at the odd multiples of pi over 2. Because the graph is undefined there, function's undefined there. So using math symbols, this is how we write it. Similar domain as we had for the tangent function. Set of all real numbers, x is not equal to the quantity 2k plus 1 times pi over 2, as long as k is an integer. And this expression right here, 2k plus 1, means an odd number, odd multiple of pi over 2. The range, looking at the graph, the y values, here I colored them in pink. Looks like y is 1 and anything bigger keeps going up. Over here, y is negative 1 and everything smaller. So using the math symbols, we write that the set of all y such that y is a member of the reals. Y is greater than or equal to 1, or y is less than or equal to negative 1.